Welcome to EDU World Space.
This question is asking us if three different metal complexes are chiral. And we start out by looking at this tetrahedral zinc-base complex. So we're going to draw this out as zinc, where we have one thing coming out at us and one thing going away from us. We have, can put our OH2, OH2, chlorine, chlorine. The way that we know if something is chiral is whether or not its mirror image is superimposable or not. And so we'll draw that mirror image. And we have chlorine, chlorine, OH2, OH2. And from this mirror image, if you were to take a modeling kit, which I highly recommend using, and looking at the plane that goes through the OH2 and the metal and rotate about that axis, you can get back to this structure from this mirror image, indicating to us that this molecule is not chiral. For part 2, we have this octahedral trans complex, where if we draw this, we start with the RU down, and then we have at us. There we go. Away from us, coming out at us. Now this is the trans isomer, so that's going to put these 50, which I'm going to draw using just the line going across this, because they are on the opposite sides of each other, and again the chlorine on the opposite sides of each other as the trans structure. And if we draw the mirror image of that, we again have the RU down, out at us. Again, we have the 50, the chlorines out, and these two are identical, and so this molecule is not chiral. Part C is the same as part B, but it's the cis isomer, and so we're going to start by drawing that RU down, where we have the BIP running from here to here, the BIP running from here to here, chlorine, chlorine, and if we draw this mirror image, we have RU down, back, where we have the chlorine here, and then we have this BIP and this BIP. And again, I highly recommend using a modeling kit for this because it'll be easier to visualize, where these two molecules are no longer superimposable because of the directionality of this bidentate ligand here and here. And so this molecule is chiral.